we're going to be talking about trigonometric identities. Now, an identity is just where two values are equal to each other. So right here we have tan theta equals sine theta over cosine theta. Now, they don't have to look the same, they just have to have the same value. So this is the first one we're going to look at with our trigonometric identities. So tangent of theta is equal to sine theta over cosine theta. Let's show why this is true. Things we need to know first is we need to remember that tangent of theta is opposite over adjacent. It's the ratio of the opposite to the adjacent. So opposite over adjacent is the same thing as tangent of theta. We also need to remember that sine theta is opposite over hypotenuse. Opposite over hypotenuse gives us sine theta. Cosine of theta, adjacent over hypotenuse. Those are going to help us show that tangent of theta is equal to sine theta over cosine of theta. Remember, I just used theta here as an angle. I could have named that angle anything. So first, let's look at sine theta over cosine of theta. We're going to replace them with their ratios. Sine theta is the same as opposite over hypotenuse. Cosine theta is the same as adjacent over hypotenuse. That is equal to, we're going to take that and we're going to multiply it by a special one. Really, I could just do this as a division problem. I have two fractions. I'm dividing them. I could flip the second one and multiply, but I like to look at it this way. So I'm multiplying it by a special one, which doesn't change the value, h over a over h over a. Now what that's going to do, it's going to give my denominator a 1. It's going to make it be a 1. The a's will cancel each other. The h's will cancel each other. AH over HA is the same thing as 1. Then I just have my top to deal with. I have opposite over hypotenuse times hypotenuse over adjacent. So I have this over here, opposite over hypotenuse. That's not a 0, it's an O for opposite. Opposite over hypotenuse times hypotenuse over adjacent. And that's going to cancel out those H's and make that a 1. And then I'll have opposite over adjacent, which is equivalent to tangent of theta. So I've shown that sine theta over cosine theta is equal to, is an identity of tangent of theta. Let's look at another very popular identity. Sine squared plus cosine squared is equal to 1. So when we're looking at this, we're actually going to use the Pythagorean theorem to help us. We've got our right triangle right here. We've got our angle theta. This represents opposite, adjacent, and hypotenuse. And we know from the Pythagorean theorem that a squared plus b squared equals c squared. We also know that sine theta is equal to opposite over hypotenuse, and cosine theta is equal to adjacent over hypotenuse. So I have opposite squared plus adjacent squared is equal to the hypotenuse squared. And that's where I'm just doing my sides, my side length a squared. I'm taking this side and squaring it. B squared, which actually is equaling a squared. This is a different a squared than our Pythagorean theorem. So my two sides squared is equal to the square of my hypotenuse. Is equal to the square of this hypotenuse right here. So now that I have this, I can actually divide both sides of the equation by an h squared. So divide this side by an h squared, divide both of these terms by an h squared. And then I can take out, since this is squared and this is squared, that's the same thing as O over H squared. So I'm just going to replace that right here. And then I'm going to add to that A squared over A over H, the whole thing squared. And H squared over H squared just gives us a 1. Now by definition, opposite over hypotenuse equals sine theta. And adjacent over hypotenuse equals cosine of theta. So I can replace that. Now when I write this squared right here, that's the same thing as taking sine theta, the whole thing, squared. They just like to write this. This is just a convention that mathematicians like to do. And when I have h squared over h squared, I get 1. So I have a 1 here. So I have sine squared plus cosine squared theta. Sine squared theta plus cosine squared theta is equal to 1. Let's look at another identity. And we're actually going to use both of the other two identities we just looked at to check out this identity. Tangent squared theta plus 1 equals secant squared theta. So we're going to start with using this identity we looked at the last board. Sine squared theta plus cosine squared theta equals 1. Now if we divide everything by a cosine squared theta, divide sine squared theta by cosine squared theta by cosine squared theta, and 1 divided by cosine squared theta, we can rewrite this with parentheses around the whole thing squared. This squared and this squared, we can write that as the whole thing squared plus 1. We have cosine squared theta over cosine squared theta. That's equal to 1. And then 1 over cosine of theta, that is just the reciprocal. And the reciprocal of cosine theta, remember, is secant squared theta. The reciprocal of cosine is secant, and the reciprocal of cosine squared is secant squared theta. Now this, from our first example, sine over cosine is going to give us tangent. So we have tangent squared theta plus 1 equals secant squared theta. Now let's look at one last identity. There are many, many trig identities. This is only the beginning. We have 1 plus cotangent squared theta equals cosecant squared theta. So cotangent, oftentimes this is written with the cotangent squared first. I like to write it like this, and you'll kind of see why as I go through. So sine squared plus cosine squared theta equals 1. It's a lot like the other one. We're going to start with our identity here. And then I'm going to divide everything by sine squared theta. So sine squared theta divided by sine squared theta, cosine squared theta divided by sine squared theta, and 1 divided by sine squared theta. So sine squared theta over cosine squared theta, sine squared theta over sine squared theta is going to give us a 1. And then cosine squared theta over sine squared theta, I'm going to take the squared out there, and so I just have cosine theta over sine theta is equal to, this is the reciprocal of sine of theta, of sine squared theta, and that's going to be cosecant squared theta. Now I'm going to rewrite this right here because this is just the reciprocal of tangent theta as cotangent squared theta. So then I have 1 plus cotangent squared theta equals cosecant squared theta. Now this is another identity. So if I have something that looks like this, I have cosecant squared theta, I can write it as 1 plus cotangent squared theta. It's the same thing. If I see 1 plus cotangent squared theta, I can replace that with a cosecant squared theta because they're identical. They're an identity.